Okay, good. All right. So I saw that you've done your work as well. Okay, that's good. So later I'll tell you about the answers. Can Zifang, this is actually the mock exam revision part 3. So what do I mean by that? Your whole exam paper is split into 4 parts. Okay, if you know about the mock exam paper, if you're unsure, no worries. After the class, I can go through with you. So this is the 3rd part. The last one will be next week. Okay, so the 4th part of the mock exam is going to be next week. Then we will add up all the marks together. Can? So if you missed out the first 2, not to worry, okay? You can actually look at the video or the recording for the 2 tutorials, which is the first and second part of the mock exam paper. Can, Zifang? Okay, so I'll just continue. Now, this is actually the this is actually our mock exam, which is replacing the mid-year exam in school, because MOE schools do not have mid-year exams anymore. So that means you don't have a chance to actually sit for a paper that will test you on all the topics you've learned before. Okay, like for science, you have done at least 4 chapters, right now. Some of you probably 5. Okay, so need to put all these questions together and test you at the same time so that you know whether you are able to cope. Okay, if you are not able to cope, then you need to do something about it, which is why we will finish by next week, right? So you have another like 2 weeks before school starts. Okay, so that 2 weeks, you need to start preparing for your revision. You have to look through all the weak areas once more. Okay, this is applicable for everybody. Okay, look at question 1 now. Which statement here about elements and compounds is true? So, of course, you know which topic this belongs to, right? Okay, I don't need to tell you what are the topics because you have done the first 4 or 5 chapters already in school. Okay, so if you can see, all right, so this particular question is about elements and compound. Tell me something that you remember about elements. Anything that you remember about elements, just have to type into the chat so I know that you're following. All right, Zifang, you need to type also lah. Heidi, you need to also do that. And Elliot, you try your best because Elliot, this is not your syllabus. Okay, but I know you can remember some things. Okay, what do you remember about elements? For example, where can you find elements? There is this very special table where you find, yeah, Evan, correct. Okay, where you find all the different elements, right? It's called the periodic table. That's right. Okay, so periodic table have got all the elements discovered, okay, listed there. And then in the periodic table, you have the elements arranged in certain way, correct or not? So it's actually according to the proton number, if you still recall. Okay, what is the proton number? Maybe I can open up the periodic table and show you all quickly. So Zifang, you should be familiar with the periodic table by now. Okay, so let me just share this now. Okay, I've sent a copy to each of you also. So if you have your own copy, you want to refer to it, that's fine. Periodic table of elements. Okay, so you will see many alphabets and you will see many names together inside each of the square. Okay, so in the square, you also have numbers at the top as well as at the bottom. So the number at the top shows you the proton number. And this is how the various elements are being arranged. So hydrogen, proton number 1, helium, proton number 2, and then lithium is 3, beryllium is 4. Then as you go along, you can see that it's increasing 5, 6, 7, 8, 9, 10, 11, 12, and so on. We don't arrange them according to the relative atomic mass. Why is that so? Because even though it's still like in increasing trend, right? Sometimes you jump certain numbers, right? Like hydrogen 1, you jump to helium 4. Okay, and then you also have elements with the same relative atomic masses. Can you see that? Cobalt and nickel. Okay, so it's 59 and 59, exactly the same. Of course, there's another set you can find lah. You look for it yourself, okay? Then, okay, so I explained already, is arranged according to increasing proton number. Then we also talk about the horizontal rows, right? Recall that? Horizontal rows are known as the period. And then vertical column, they are known as the groups. Still recall, so all these are important. Now, the elements are usually represented by one capital letter, okay? If you have two letters representing the element, the second letter will always be a small letter. That's how you recognize whether the letter belongs to the element or it's an element itself. What do I mean? I will just quickly annotate on our slides. For example, if I have something like this, maybe K and then I. This is potassium iodide. So this is actually the element potassium. And then another one over here, this is actually iodine. You can find that in the periodic table also. Then if I have something like Si, capital S, small I, this is silicon, which is one element on its own. Okay, because this is the small letter. All right. So you can find this in the periodic table as well. Now, let's come back to this question. Which statement about elements and compounds is true? Now, can elements and compounds exist as molecules? Yes, they can. Let me show you. So let's talk about the elements first. Example, oxygen. Oxygen, if I'm talking about just atoms on its own, yeah, this is oxygen atom, but it can also exist in the form of molecules. For example, oxygen gas. So this is O2 molecule. I can also have ozone, O3 molecule. So these are actually atoms and molecules of element oxygen. Can you see that? So yes, elements can exist as molecules as well, not just elements in the periodic table, that's it. Okay, they can be in the form of molecules. Compounds, let's look at compounds. Compounds is actually made out of what? You must know the definition of compound. Okay, definition of compound. We can say that compounds is actually made up of two or more elements. Must know this definition. Okay, chemically combined together. So for example, I can have carbon dioxide. Okay, so in this case, I can write down carbon dioxide, CO2. This is actually made out of two elements, carbon and oxygen. This is carbon dioxide molecule or carbon dioxide gas. This is a molecule. What is a molecule? Okay, if you are supposed to define molecule, is defined this way. So molecule is actually made up of two or more. We don't say elements now, we say atoms. Okay, so made up of two or more atoms chemically combined together. Or chemically combined is fine. Okay, so made up of two or more atoms. So the atoms can be of the same element or different elements. Of course, not every single element, right, can have their atoms combining to form molecule. Okay, not all, only some of them. Like oxygen is one of it. Hydrogen, you can have it also. Chlorine also. Fluorine as well. So these are some examples only. All right, so far? Can you understand this part here? If you all can understand, give me a thumbs up. Up to this point, can understand, give me a thumbs up. Okay, good, Elliot. Thank you, Evan. Thank you, Zifang. Heidi, you okay, Heidi? Okay, great. Now, so Let's look at the second statement now. Elements and compounds cannot be broken down by chemical means. I will say that compounds can be broken down by chemical means, but elements cannot, because elements are already the simplest form that you can find. Okay, so this is already the simplest form. You cannot break it down any further. Whereas compounds, for example, we learned water, right? We talk about water. It can be actually separated into its elements by this process known as electrolysis. Okay, just write down somewhere. You will revisit electrolysis in Sec 2. Okay, so water, electrolysis allows the breakdown into hydrogen gas and oxygen gas. So this is extra info for you, okay? So electrolysis allows the breakdown into H2 and O2, hydrogen gas and oxygen gas. So electrolysis is actually a chemical method. So this is a chemical method for separation, right? Chemical method. So this statement already tells us that it is not correct. Look at statement C. Elements exist only as atoms. Compounds exist only as molecules. Compound must be molecules, of course, because it's more than one element, right now. Okay, so minimum you should have two atoms combined together. Whereas elements can exist as atoms. Okay, but it also can exist as molecules. So you don't use the word only. The word only causes it to be a wrong statement. All right, so both atoms and molecules. So only I will put a cross here. Elements can be broken down by chemical means, while compounds broken down by physical means. Okay, this is not true. Elements cannot be broken down at all. So this part is wrong. Compounds can be broken down by physical means. This is a wrong word here. Should be chemical. All right, so I've annotated on all the necessary parts of this question. Write down the notes that you need to write down, and then we will go on to the next one. Okay, so Evan, I saw that you made the wrong choice in the question 1. You understand now, huh? Okay, because you probably thought, because everything in the periodic table is the element, and they are all single on their own. You thought that it's only the atoms. So now you have example, O2 is a molecule. O3 ozone is also molecule. Right. Let's continue. Which of the following cannot be separated by physical means? Now, let's go through one by one. Okay, physical means and chemical or physical methods and chemical methods are very different. Physical methods will be those that you have learned, like filtration, magnetic separation, evaporation, crystallization, distillation, etc., etc. The chemical methods are more extreme, like electrolysis. We have to make use of electricity, pass through the electric current into the substance to break it down. So that one is an extreme method, it's a chemical method. All right, so chemical method are very extreme. Extreme with an inverted comma. You don't use it in your answer. It's just for you to understand. You have to even use a lot of energy, that kind of thing. So chemical methods are extreme in a sense that electricity and very strong heating are involved. Okay? Sometimes you need to even adjust a lot of these, you need to adjust even the pressure, etc. Okay, but you don't have to know at your level now. It is more important for you to actually know that, okay, chemical methods is very, very different from the physical method. Okay, like simple heating in the science lab can already allow that to happen. But the setup for electrolysis, which